Hi everyone, this is Mr. Leclerc. Hope you're all well. This is our first video on 8F, our learning target, inverse trig functions. Before we do inverse trig functions, I want us to turn to page 41 and take a few notes about the coordinate plane. We're going to look at a few examples and learn how we can determine which quadrant an angle is in based upon the sign of the trig function at that angle. We're going to see a few examples like that on Delta Math assignment as well. Okay, so when we're referring to the coordinate plane, let's imagine that on page 41, this is our coordinate plane. So this is our x-axis, and this is our y-axis. Remember that the coordinate plane is broken up into 4 quadrants. We call the upper right quadrant, quadrant 1. We call the upper left quadrant, quadrant 2. We call the bottom left quadrant, quadrant 3. And we call the bottom right quadrant, quadrant 4. Now remember, on the coordinate plane, as we go left and right, our left and right directions refer to the x-axis, or our x-coordinates. And as we go up and down, our up and down directions refer to our y-coordinates, or our y-axis. And as we go to the right, our x-coordinates are positive. And as we go to the left, our x-coordinates are negative. Similarly, as we go up, our y-coordinate is positive. And as we go down, our y-coordinate is negative. Okay, so that's just a few things about the coordinate plane. Now let's see how it relates to the unit circle. So on the unit circle, the cool thing about the unit circle is that we can really think of it as a circle actually on a coordinate plane. In other words, the same rules apply. As we go to the right, our x-coordinates are positive. As we can see, they are. As we go to the left, our x-coordinates are negative. As we go up, our y-coordinates are positive. And as we go down, our y-coordinates are negative. But remember that on the unit circle, our x-coordinates we call cosine, and our y-coordinates correspond to sine. In other words, we can think of our x-coordinates as cosine, and we can think of our y-coordinates as sine when we're referring to the unit circle. So we can change our x's to cosine, and the same rules apply. So as we go to the right, cosine is positive. As we go to the left, cosine is negative. And similarly, since y corresponds to sine on the unit circle, as we go up, sine is positive. And as we go down, sine is negative. Okay, now let's just take a look at each quadrant individually and figure out the signs of sine and cosine. So in quadrant 1, in order to get to quadrant 1, we need to go to the right and up. That means in quadrant 1, cosine is positive and sine is positive. They're both positive in quadrant 1. In quadrant 2, we need to go to the left and up. That means in quadrant 2, cosine is negative and sine is positive. In quadrant 3, in order to get to quadrant 3, we need to go to the left and down. That means in quadrant 3, our coordinates, cosine is negative and sine is negative. So in quadrant 3, both cosine and sine are negative. And then finally, in quadrant 4, to get to quadrant 4, we need to go to the right, where cosine is positive, and we need to go down, where sine is negative. So in quadrant 4, cosine is positive and sine is negative. Okay, so now let's take a look at some examples. The first example is asking us, in which quadrant does theta, remember theta is just an angle, I'll go ahead and write that, theta is an angle. So in which quadrant does an angle lie if the following statement is true? Sine at that angle is greater than 0. So let's remember what that statement means. Sine is greater than 0. If we just have some number, I'll just choose it, call it a. If we have some number a greater than 0, that just tells us that that number is positive. Similarly, if we have some number a less than 0, that just tells us that number is negative. So when it says that sine is greater than 0, all that means, when it says sine is greater than 0, all that means is that sine is positive. I'll go ahead and try and make that look better. There we go. Sine is positive. So what this example is actually asking us is, in which quadrant does some angle lie for sine at that angle to be positive? In other words, in which quadrant is sine positive in? So let's go ahead and look at our coordinate plane that we did on page 41. So we want sine to be positive. We know sine is positive when we go up, and that can happen in two places, in quadrant 1 and quadrant 2. So we must have an angle in quadrant 1 for sine to be positive, and we can have an angle in quadrant 2 for sine to be positive. So we have two answers here. Quadrant 1 and quadrant 2, because sine in both quadrants is positive. So for our answer, we write quadrant 1 and quadrant 2. Cool. Now let's look at another example. This next example is probably a little bit closer to something you might see in your Delta Math assignment. So this one is asking us, in which quadrant does some angle lie if the following statements are true? Sine is greater than 0, and cosine is less than 0. Remember, when it says that sine is greater than 0, that just means that sine is positive. When it says that cosine is less than 0, that just means that cosine is negative. So we want to figure out which quadrant sine is positive in, and at the same time, cosine is negative in. So let's take a look at our diagram again, our coordinate plane. I'll go ahead and erase the last answers we wrote. Okay, so again, we want sine to be positive and cosine to be negative. Let's just start with sine. In which quadrants is sine positive? We know that sine is positive in quadrant 1 and quadrant 2. So our answer must be in either quadrant 1 or quadrant 2. But where is cosine negative? Cosine is negative as we go to the left, in quadrant 2. In other words, our answer must be in quadrant 2, because in quadrant 2, sine is positive and cosine is negative. So that is where our angle lies. For that to happen, cosine to be negative and sine to be positive at the same time. That only happens in quadrant 2. So our answer for this example is quadrant 2. Okay, cool. Now let's go ahead and look at another example. This one will involve tangent. So this one is asking us, in which quadrant does some angle lie if the following statement is true? Tangent is less than 0. So remember, tangent less than 0 just means that tangent is negative. So in which quadrant does some angle lie that makes tangent negative? So in order to answer this problem, we need to remember what tangent is defined as. Let's go to our unit circle on page 34. So our unit circle on page 34 says that tangent is our y-coordinate over our x-coordinate, or sine over cosine. So I'll go ahead and write that on our example. So tangent is sine divided by cosine. Okay, so how does that help us answer this question? Well, it tells us something about the signs. So when can tangent be positive and when can tangent be negative? Let's look at the positive cases first. So tangent can be positive if sine is positive and cosine is positive. Because when you divide a positive number by a positive number, you get a positive number. I'll make that look better. There we go. Okay, but remember also that a number can be positive if the bottom and the top are both negative. So if sine is negative, divide by a negative cosine. Tangent can also be positive when sine is negative and cosine is negative. Now let's look at when tangent can be negative. Tangent can be negative in two cases also. If sine is positive, while cosine is negative. Because when you divide a positive number by a negative number, you get a negative number. And tangent can also be negative the other way around, if sine is negative and cosine is positive. Because similarly, when you divide a negative number by a positive number, you get a negative number. Okay, so let's go back to our problem. It's asking us, in which quadrant does some angle lie that makes tangent negative? So we know that tangent can be negative in two cases. It can be negative in this way, and it can be negative in this way. So we probably have two answers here. We need to find two quadrants such that both of these are met. So let's see. Let's look at this one first. So sine is positive and cosine is negative. Now it's kind of like the last problem we did. In which quadrant is sine positive and cosine negative? So we know sine is positive in quadrants 1 and 2 above our x-axis. And we know that cosine is negative when we go to the left. So quadrant 2 must be one of our answers for our angle, because in this quadrant, tangent will be negative. Oops. Quadrant 2. Okay. Now let's look at our other case. That one's asking us, where is sine negative and cosine positive? So we know that sine is negative in quadrant 3 and 4, below the x-axis. And we know that cosine is positive when we go to the right. That means our angle must be in quadrant 4, because sine is negative and cosine is positive in that angle, in that quadrant, I mean. And when that happens, tangent is negative. So our other answer for this example is quadrant 4. Okay. Now let's look at one more example. So this one is asking us, in which quadrant does theta lie if the following statement is true? Tangent is greater than 0 and sine is less than 0. Again, that just tells us that tangent needs to be positive, and that tells us that sine needs to be negative. So in which quadrant does an angle lie such that tangent is positive and sine is negative? So let's just remember tangent again. Tangent is sine divided by cosine. So what do the sines on sine and cosine have to be? That can happen for tangent to be positive. That can happen in two ways. Again, sine can be positive and cosine can be positive, because when we divide by a positive number, we get a positive number. But also when we divide a negative number by a negative number, we get a positive number. So we can have two cases here. But we know that sine needs to be negative. So if sine also needs to be negative, we know we're not in this case, because in this case sine is positive. So that means we must be in this case. So sine needs to be negative and cosine needs to be negative. So the question is really asking us, in which quadrant is sine negative in? At the same time, cosine is negative. So let's go look at our coordinate plane again and look for where sine is negative and at the same time cosine is negative. In fact, go ahead and pause the video. Try to find it on your own. In which quadrant is sine negative and cosine negative at the same time? Okay, did you find it? So we know that sine is negative when we go down. So we're either in quadrant 3 or quadrant 4. And cosine is negative when we go to the left, sorry. That means we're in quadrant 3, where sine is negative and where cosine is negative. So our answer must be in quadrant 3. Because in quadrant 3, tangent is positive. Since when you divide by negative and a negative, you get a positive number. and in quadrant 3, sine and cosine are both negative. Cool. So that concludes this video. You should be able to do your online math homework now. In the next videos, I'm going to go over problems A through F on page 42. If you're not taking calculus next year, you don't need to worry about problems D through F. But if you are, then you need to watch all the videos. If you are not taking calculus, then you only need to watch problems A through C. Good luck, guys, and I'll see you in the next video.